So 211, percent increase and decrease. Hopefully this stuff looks familiar from last year, so I'm really hopeful that it'll go pretty nice for you. You'll recognize it. Life will be good. And it's the final installment in kind of several sections now where we're looking at doing stuff with percents. So I want to start out just by giving an equation. I'm going to put it in red for dramatic emphasis. But the percent change, so if you're trying to find the percent change in something, it's going to be the change divided by the original. So the change, how much something goes up or down, divided by the original amount. And I'm just going to throw in a couple quick examples. So if we're going from the number 15 to 40, last year I sold 15 entertainment books. This year I sold 40. What's my percent increase? And so the change from 15 to 40 would be the difference. So we subtract them, right? And so to figure out what that change is, that would end up being 25. Divided by the original is 15. Because originally I sold 15. That changed to 40 this year. So I'd have 25 over 15. If I punch that in my calculator, I get 1.6 repeating. Or maybe that'd be a little more clear if I just wrote 1.6666. Throw a bunch of sixes in there. So we have this decimal. What percent is that decimal? If you change from percent to a decimal, you move the decimal point how many places? 2. So if you want to change it back, you have to move it 2. So we have to decide, and I kind of gave it away by writing the 1. It would either be this way, like 0.016%, or it would be the 166%. The correct answer is? 166. Yep. So it's 166 points, you could say 6 repeating, maybe 166.7%, something like that. But if something grows from 15 to 40, it's 166% increase over the year before. We okay on that one? If we're going the other way, so now my younger sibling's selling same time as me, so I sold 12, and now maybe do an arrow, but 12 turns into 3. So if I do that, my change is going to be 12 minus 3, or 9. So kind of the difference between the two, the change. And then if I take and divide that by 12, I get a 0.75. 0.75 would be what percent? 75%. So it's a 75%, maybe I should say for this first one, increase, and a 75% decrease.
Wait, for the first one, why do you do 40 minus 15 over?
The second one maybe would have been more clear if I would have done the 12 minus 3, because we're trying to figure out what's the change, by how much does it go up or down, and divide that by the original. Is that a little more clear seeing it that way? So you're always trying to figure out kind of what's the difference between those numbers. The change is going to be the difference. Number 2, increase by a percent. This I know we did last year. Increase by a percent. And kind of the key, I'm going to put it in red for dramatic emphasis, keep 100% and add a percent on. So keep 100% and add a percent on. What some people do, maybe I'll do my example, then I'll talk about what some people do. So I'm going to say my example is that sales, bless you, sales go up by 20%. And I'll maybe say they were 57,000 last year. So trying to keep the question kind of short. So last year the sales were $57,000. They're going up by 20%. What would it be this year? What some people do, here's the way I like doing it. If something goes up by 20%, do you agree their sales this year are now 120%? Because they sell the same amount, they sell 100%, but they sell 20% more than the 100%. So what I would do if I were you, what I like is saying, okay, if it's up by 20%, that's really just 120%. So I'm going to say it's 120%. How would I write 120% as a decimal? 1.2 or 1.20 looks a little bit more clear to a lot of people. So when we go back to that equation we'd been doing where you have the percent times the whole equals the part or equals the partial, I'm going to put in a 1.2 or 1.20 for my percent. Now the whole is going to be, well, how much money was it last year? how much money are we changing? We're trying to find 120% of what number? That's 57,000. If I take and punch that in, I end up getting 68,400. I like that because it's all one step. So I'm going to say this here is way number one. You don't have to write this unless you're going to write the second way. I like this. It's one step, I'm done. What some people choose to do, and I'd say it's very legitimate to choose just not to put this in your notes. So there's no pressure on my end to put it in your notes. But what some people do is they say, I'm going to find the 20% of that 57,000, and then they add it to the 57,000. The reason I don't like this as much is because I've seen a lot of people, they find the 20%, they say that's their answer. But what you could do when you do that percent times the whole equals the part is they do 0.20, what's 20% of 57,000. So they say, okay, 20% is going to be 11,400. So that right there is that 20% of the sales from the year before. That's how much their sales grew, because it grew by 20%. It went up by $11,400. So your final step then has to be 57,000 plus 11,400. And you get that same answer of 68,400. You just have to do a second problem. I'd rather just say 1.2 instead of 0.2 and add it. But if the first way doesn't make sense to you, then by all means do it this way. Roman numeral 3, decrease by a percent. When we increased by 20%, we added 20 to 100. If we're going to decrease by, say, 15%, we would...
100 minus.
Yeah, perfect. You do 100% minus that number, so 100% minus 15 in that one. So I'm going to, in red, for dramatic emphasis with a star, say take a percent away from 100. So take a percent away from 100%. So that's the way I prefer to do it, and I'm going to show that way first. But I'm going to say, okay, an example. The number of hot lunch eaters decreases by 40%. Or maybe I should write in the other order. So 127 people eat hot lunch. Then they stopped buying the subs from Subway, and there was mass anger in my classroom. Okay, so we're going to say it goes down by 40%. They're just not as good. Down by 40%. What I would do then is, so the way I like seeing it is 100%, take away 40%, and you don't have to actually write this out. Most of you would just say, if you're taking off 40%, what percent is left? Exactly. So you're really trying to figure out, well, what's 60% of the year before? Because they took off 40%, there's 60% left. So then when you do your percent times the whole equals the part, our equation from a couple sections ago, 60% would be 0.6, or I'll do 0.60 because it helps some people see that it's 60%, but if you're not watching, I just do 0.6, times the whole, which is my 127 people. Punch that in, and I get 76.2. I'm going to just round it to 76 because we're talking about people. So I'll do 76.2. And then cut off my 2 at the end. That's the person that eats 1/5 of their sub and then says, I'm not going to eat it. So,
That's it.
if you want to write it the second way, you're welcome to. This is way number 1. If you like this way, feel free to skip writing the second way. Feel free to just kind of not do it. But if you're looking at that and you're like, I'm going to forget to subtract 40%. I know I'm going to get these wrong. Then you might want to say this one. So this is the way number 2. So for that, what you would do is you'd first find out what's 40%. So when we do our percent times the whole equals the part, well, we're losing 40%. So if I do 0.4 or 0.40 times my 127 people, what I just found was how many people stopped getting lunch. Because 40% of people stopped getting lunch. It went down by 40%. So here I get 50.8. Or I'll maybe just say, okay, that's approximately equal to 51. So 51 people decided, I'm not getting lunch anymore. But then you have to remember to say, okay, I'm going to take my 127 lunch eaters. Now 51 people aren't getting lunch, and that'll get me down to my 76 people that still are. So pick the way that works for you. Do them. Survive. Life is awesome.